Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the given graph of prime of f at x to find the graph of f at x. So as per the problem, the following graph represents the derivative function prime of f at x of a function f at x. Determine the intervals where f at x is increasing, the intervals where f at x is decreasing, and x coordinates for all local extrema of f at x. Assuming f at 0 equals 2, make a rough sketch of graph of f at x. So we'll start by analyzing the given graph for prime of f at x. Now this graph is a parabola that is opening upward and it has two x-intercepts. And the x-intercepts are at x equals -1 and x equals 1. Now on the left side of this x-intercept -1, the graph of prime of f at x is above the x-axis. That means to the left side of this x-intercept -1, the prime of f at x is greater than 0. Similarly, to the right side of the x-intercept 1, the graph is above the x-axis, so prime of f at x is greater than 0. Now, in between these two x-intercepts, the graph is below the x-axis. That means between these two x-intercepts, the prime of f at x is less than 0. So we'll use this information to write the intervals in which the function f at x is increasing and decreasing. So let's start with the increasing intervals. Now we know that an interval in which a function is increasing is the one in which the prime of that function is greater than 0. So the first interval in which this function is increasing is from -infinity to -1. So all x values to the left side of -1. And this function is also increasing to the right side of 1. That means all x values from 1 to positive infinity. Now these intervals can be written in the inequality notation as x is less than -1 and x is greater than 1. Now we can write the intervals in which the function is decreasing. So the intervals in which this function is decreasing is the one in which prime of f at x is less than 0, and that's between -1 and 1. So we can write that in interval notation as -1 to 1. And in the inequality notation, we can write it as x is greater than -1 and less than 1. Now we can find the x coordinates for all local extrema. Now for that we'll analyze the two x-intercepts. So at x equals -1, the sign of prime of f at x changes from positive to negative because at x-intercept -1, the graph goes below the x-axis from left to right. So as a result, there is a local maximum. At x equals -1, because at x equals -1, the function changes from increasing function to decreasing function. Now we can analyze the other x-intercept. At the other x-intercept, as we go from left to right, the function, the prime of f at x changes sign from negative to positive as we go from left to right. So the graph of prime of f of x passes through the x-axis. So as a result, the function changes from decreasing to increasing. So therefore, there is a local minimum at x equals 1. So there is a very important concept we need to understand and memorize about this analysis for prime of f at x graph. Now we can use this information to graph f at x. So first we'll identify the given point that lies on f at x, and the given point is 0, 2, and that lies on the y-axis. Now we have identified that there is a local maximum at negative 1. So at negative 1, the graph changes from becoming increasing to the left side to decreasing to the right side of this local maximum. So at x equals negative 1, we can show the graph like this. And so to the left side, it will just extend because the graph is increasing all the way from left to right up to x equals negative 1. Now between negative 1 and 1, the graph is decreasing, so we can show it going down and then passing through this given point. And at x equals 1, it turns back upward as we go from left to right. So after x equals 1, the graph starts going back up. So this can be the sketch of f at x. So we can see the function is increasing to the left side of negative 1 because any tangent we draw to this function has a positive slope, and it's decreasing between negative 1 and 1 because any tangent we draw to this function has a negative slope or sloping downward, and this function is increasing to the right side of 1 because any tangent we draw to this function has a positive or upward slope from left to right. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to analyze the graph of prime of f at x very carefully in order to identify the key features of the graph of f at x and then sketch it. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.